Hi, hello, and welcome to RRR Series, Read, Revise and Repeat series from StudyMedic Group for the course EPCOG on the topic Biostatistics and Research Methodology. This is Dr. Avinash SS, mentor at StudyMedic Group. In this RRR series, we will be revising briefly on variables, measures of central tendency and dispersion, representation in graph, normal distribution, confidence interval, hypothesis testing and types of errors, inferential tests, study design, effect estimates, and diagnostic accuracy tests. Coming to the first topic, what are variables? Variables are characteristics of interest of a population observed or recorded. What are the different types of variables? Variables may be categorical, that is qualitative, or numerical or quantitative. Now, categorical variables can be measured either in nominal scale or ordinal scale. Nominal scale variables are naming variables which are mutually exclusive. For example, marital status, type of occupation, nationality, blood group, etc. Ordinal variables are always ordered. The difference, however, between the order, grade or scale is not exact. For example, socioeconomic status, education level, grade of satisfaction, risk status, or severity. Now, numerical or quantitative variables can be either discrete or continuous. Now, discrete variables are nothing but counts. They can assume only whole numerical counts. They cannot assume any other values in the spectrum. For example, number of children, visits, admissions, heart rate, respiratory rate, etc. Whereas the continuous variables can assume any value in the spectrum. They can be either have a no true zero or has a true zero. If they are measured in interval scale, they can be called as having no true zero. They cannot be expressed as ratios. For example, temperature in degree Celsius, Fahrenheit, IQ, pH, etc. And those which has true zero can be expressed as ratios. For example, temperature in Kelvin, age, height, etc. To know exactly what is the difference between interval and ratio with explanation, please do subscribe to StudyMedic. Now let us discuss about the measures of central tendency. The most important measure is the mean. Mean is sum average, sum of all values divided by the total number of values. It is affected by extreme values. It is appropriate only when the data is normally distributed because it is affected by the extreme values. Whereas median is the centralmost data in a sorted set of data. It is calculated as n plus 1 by 2th value when n is odd, or average of n by 2th value and the next value when the n is even. It is not affected by the extreme values. So it is appropriate when data is normally distributed. Now, how to calculate median from a set of data? To know that, please do subscribe. Now, what is mode? Mode is the most commonly recurring data. It is appropriate to represent most commonly occurring events like number of type of deliveries, type of presentation, etc. Now, coming to measures of dispersion, most important is the standard deviation. It is the square root of variance. Okay, standard deviation is usually calculated by square root of sum of squared mean differences divided by n. It is affected by extreme values similar to mean. So it is appropriate when data is normally distributed and used always along with the mean. What is interquartile range? Another measure of dispersion. Interquartile range is the difference between quartile 3 and quartile 1. Now, what is quartile 2? Quartile 2 is nothing but the median. Quartile 2 is calculated as half of n plus 1th value, also called as the 50th percentile, whereas quartile 3 is calculated as 3 by 4th of n plus 1th value, which is called as the 75th percentile. Quartile 1 is calculated as 1/4 of the n plus 1th value, that is called as the 25th percentile when n is odd. It is again not affected by the extreme values, and it contains 50% of the data within it. So it is used appropriately when data is not normally distributed along with the median. And to know how to calculate interquartile range from a set of data and other details, do subscribe. Coming to the representation by graph. Now, bar graph represents the categorical data and its distribution. You can see the bars here are not attached, whereas the histogram represents the relationship between continuous data versus the frequency distribution. Here you can see the bars are attached with each other. Using this histogram, we can also find out the type of distribution. Now, how to find out what are the other characteristics? Please do subscribe. The other representation by graph includes the scatter plot. Scatter plot, as the name indicates, you can see is having many scatters. It represents the association between the bivariate data. For example, strength and direction of the relationship between the height and weight. And also find how to find out the strength and how to find out the relationship and the significance. To know more, please do subscribe. Then box whisker plot. You can see it represents the categorical data versus the frequency. For example, diastolic pressure distribution in males versus females. You can see that it contains a square. The mid part of the square is the median. The upper part represents the quartile 3. The lower part represents the quartile 1. And these are the whiskers. And this is the interquartile range, quartile 1 minus quartile 3. And to know more about how to deduce information from box whisker plot and calculate further, please do subscribe. And also to find out what is the type of distribution. Now coming to normal distribution, you can see it is also called as a Gaussian distribution curve. Here the continuous variable is represented on the x-axis, whose mean and standard deviations are calculated. Mean and plus 1, plus 2, and plus 3 and minus 1, 2, 3 standard deviation are represented. And on the y-axis, probability density are represented. This graph is symmetrical. Left and right shoulders are symmetrical to each other. It is a bell-shaped curve. And this normal distribution curve always follows 68, 95, 99 rule. What is this? 68.27% of the data lies within mean plus or minus 1 standard deviation, whereas 95% of the data lies within plus or minus 2 standard deviation, and 99.73% lies between 3 standard deviation. What proportion of women are obese when the mean BMI is 25 and SD is 2.5? Such questions are asked. To solve questions, we can use the above characteristics of the normal distribution. To know more about such problems solving, do subscribe. Now, coming to confidence interval. What is confidence interval? When from a population of a particular sample size of 5, we draw another sample of a sample size of 2. And what is the probable samples? Different samples that can be drawn is n raised to n is around 25 different samples. When all the samples are drawn, each samples will have a different mean or effect estimate. When you take the distribution of this mean, you can see it is always, or when you plot the distribution of this mean, all sample probable mean, you can see all of them are normally distributed. The distribution of the sample probable mean is normal. Then what is the variation? What is the variation? The variation in this distribution of the sample probable mean is the standard error of mean. The variation in the distribution of the sample probable mean is the standard error of mean. Then what do you understand by the term mean plus or minus 2 standard error of mean? It tells us there is a 95% chance that the population mean will lie within this confidence interval. So confidence interval is an interval estimate. Confidence interval is an interval estimate which is used to calculated using sample estimate. First, we calculate the standard error of mean, which is nothing but the variation in the sample probable mean. Next, what is the standard error of mean? It is calculated as the population SD by square root of n. Because we don't know the standard deviation of the population, and since sample is similar to the standard population, we use sample SD and divided by the square root of the sample size. Then the 95% confidence interval of the mean, population mean, is equal to sample mean plus or minus 2 standard error of mean, deducing from the normal distribution. So confidence interval, width of a confidence interval is directly proportional to sample variation. That means more is the variation, more is the width. More is the width, less is the reliability of the finding. Next time when we repeat the experiment, we may get the similar different reading. Now confidence interval is inversely proportional to sample size. More is the sample size, less is the width of the confidence interval. That means the study is more reliable. Confidence interval, if it does not include the null value, then the finding is significant. For example, confidence interval of a mean difference is does not include the null value for the mean difference. For example, null value for the mean difference is 0, and the confidence interval for the mean difference does not include the null value, then it is significant. The distance between the lower level of the confidence interval and the null value estimates the effect size. To know more about the confidence interval and to calculate confidence interval from the sample mean and to solve such more problems, please do subscribe to Study Medic group. Now coming to hypothesis testing and error types. Okay. Now, what is an alternative hypothesis or the scientific hypothesis? It is a biological plausible explanation given based on our observation or experiment. For example, if we say glucose is not different between, hemoglobin is different between males and females, the null hypothesis states exactly opposite. It states there is no difference between hemoglobin between males and females. Now we know that null hypothesis, what is stated, is false. Then what our study should do? Our study should reject that null hypothesis and conclude that there is a difference in hemoglobin between males and females. Then when we correctly reject a false null hypothesis, it is called as power. It should be more than 80% minimum acceptable. Now, instead, the false null hypothesis not rejected, but it is not rejected. Then what we are doing? Then we are concluding that there is no difference in hemoglobin between males and females. That is false negative report we are giving. That is called as the beta error or type 2 error. Minimum acceptable beta error should be less than 20%. So here null hypothesis is not rejected or accepted when false is beta error, NIAF beta. Now, if our hypothesis says there is a difference in glucose between males and females, but null hypothesis says there is no difference. Now we know that null hypothesis is true. What we should have done? We should not reject this null hypothesis. Then and go on to conclude that there is no difference between glucose between males and females. So when we do that, it is called as truly does not reject a correct null hypothesis in our study. Then it is true negative. It is called as a confidence in our study. It should be more than 95%. So it is null hypothesis not rejected when true. However, instead we reject it. So null hypothesis is rejected when true. So what will happen? We conclude that there is a difference in what is that? Glucose levels between males and females. We are giving a false positive here. So it is called as the alpha error or type 2 error. The minimum tolerable alpha error should be less than 5%. So this is about hypothesis testing. So what is the null hypothesis? It states the null effect opposite to the alternative hypothesis. What is the p-value? The p-value is the probability of the study finding due to random chance. Now, if the p-value is less than 0.05, that means the probability that our study finding is due to chance is less than 5%. Then we conclude it as significant. Similarly, p less than 1% is highly significant. P less than 0.1% is very highly significant. P-value only tells us about statistical significance and not tells us about clinical significance. To know more about identifying the type of error, calculating how to calculate beta error when power is known, how to calculate power when beta error is known. Okay, and to know more about p values, please do subscribe to StudyMedic group. Now coming to inferential tests. These are the statistical tests that we use to test the significance of the effect estimate in our study. Now these inferential tests are based on what is the objective, what are the assumptions. Okay. Now if the objective is to find out the significance of difference in means between what are the assumptions, one group versus already known group, then and if it meets all the assumptions and the population is normal distributed, then we use parametric tests. Here the parametric test is one sample t-test. If it fails to meet certain assumptions and if the population is not normally distributed, then we use non-parametric equivalent alternative tests. Here the alternative non-parametric equivalent test to one sample t-test is one sample Wilcoxon test. Now, if the objective is to find the significance of difference in means between two independent groups, right? The parametric test is two sample t-test. Non-parametric test is Mann-Whitney use test. We should remember parametric tests are used when all assumptions are met and it is normal distributed, data is normal distributed. Non-parametric tests are used when it fails to meet the certain assumptions and the data is not normally distributed. For example, the two sample test is used when the difference in glucose we want to find out between normal versus preeclampsia. Now, we want to find out significance of difference in means between two related groups. Then the parametric test is pair t-test, whereas non-parametric equivalent is Wilcoxon sign rank test. For example, the difference in iron between before and after treatment group. Here the group before and after are paired, related. They are not mutually exclusive. They are the same people before also, after also. So in such case we use pair t-test or Wilcoxon sign rank test. Now if you want to find out the significance of difference between mean but not one group but more than two independent groups, it is the extension of the two sample t-test. We use one-way ANOVA. Non-parametric equivalent is Kruskal-Wallis test. Now, for example, difference in BMI, we would like to find out whether the mean is different between normal versus GDM versus PAH. There are more than two groups here. Then in case we use ANOVA or Kruskal-Wallis test. Now, if we want to find out significance of difference in means more than two related groups, then we use repeated measure analysis of variance. For example, difference in HbA1c at first month versus second month versus 3 months. There are more than two groups here, related groups. Now, significance of change in counts or proportion is our aim between more than two related groups. Then we use what is called as the McNamara test. For example, change in perception type before versus after. Here perception type is a categorical variable. If it gets changed before or after, that is two groups are related, then we use McNamara test. If it is a continuous variable and if you want to find out the change in means between two related groups, it is pair t-test. That's the only difference. Now to find out the strength and direction of the association, what do we use? What shall we use? We use what is called as the Pearson's correlation test when we use between two continuous variables. Strength and association between two continuous variables, we use Pearson correlation test. The alternative is the Spearman correlation test. For example, relationship between height and weight. Now, if you want to find out the strength and association of between two categorical variables, so what do we use between two categorical variables? It is chi-square test. When the sample size is low, we use Fisher exact test. For example, relationship between pregnancy status and GDM status. In continuation, if our objective is to predict or quantify or to find out the effect of change in continuous dependent variable from a single independent continuous variable. We use simple regression test. Here, predict the GFR. Predict the GFR from creatinine is the example. Predict the GFR from creatinine is the example. Here, GFR is the dependent variable, creatinine is the independent variable. Both are continuous and linearly associated and normally distributed. Now, if you want to predict or quantify change in continuous dependent variable again, but from multiple independent variables, we use multiple linear regression. For example, predict the GFR, from multiple independent variables like creatinine, age, gender, etc. Now, if you want to predict quantify the change in categorical dependent variables from independent variables. Now here the dependent variable is categorical. We use what is called as the logistic regression. Now here, for example, if you want to find out the effect of GDM status on pregnancy outcome, the pregnancy outcome is the dependent categorical variable, whereas effect of GDM is the independent predictor variable. In such case, we use logistic regression. Now, coming to study designs. So studies designs are classified, okay, based on whether there is a intervention or not. If there is intervention, it is interventional study design or experimental study design. Intervention in the form of either starting or initiate or stop the treatment, counseling, training, whatever it is, to change the course of the outcome. Then they are called as interventional or experimental study designs. They may be randomized. The patients may be randomized. Then they are randomized study designs, randomly allocated to intervention or control arm, placebo arm. The random, for example, RCT, clinical trials. It may be single blind, double blind, open labeled, parallel, or crossover. To know more about this and different terminologies and examples, please do subscribe to Study Medic Group. Now, if you are not randomly allocating, then it is called as the non-randomized study design, also called as the quasi-experimental study design, also called as quasi-experimental study design. Now, if there is no intervention, then it is called as the non-interventional or observational study design. Now, what are the types? They may be with control. They are analytical observational study designs. For example, cross-sectional study design with control, case control study, cohort study, retrospective or prospective. They are all analytical study designs with control, analytical observational study designs. If there is no control, it is descriptive observational study designs without control. Example, survey in small population, census in large population. Now, coming to cross-sectional study design. When we select from a population at a single point in time or a particular amount of time, duration of time, we choose a sample from that. In that sample, we measure the disease or the outcome status. Simultaneously, we measure the exposure or risk factor status. This is called as a cross-sectional study design. Examples include prevalence studies to find out the prevalence of chronic disease, non-fatal disease, very useful. To find out the status of knowledge, attitude, practice studies. Find out satisfaction or reaction levels, perception of the participants, effect on the physiological variables, effect of disease on BP, heart rate, etc. They are all examples of cross-sectional study designs. And even diagnostic accuracy studies can be performed using cross-sectional study design. The advantages is very feasible, cheap, non-time consuming, and it is used for health planning and screening. Whereas the disadvantages of cross-sectional study design are it is prone for selection bias. It cannot establish a causation. To know more about that, do subscribe. The next study design is case control study design. Here, From a population, we choose those who are already suffering from a rare case. And we choose from the same population controls which are matched. And we collect the history of exposure in both cases as well as controls. Then we find out odds of exposure in case A by B, A are exposed, B are not exposed in case, and odds of exposure in control C by D, C are exposed and D are not exposed amongst the controls. Then we calculate the ratio, odds of exposure to odds of no exposure. Now, what are the advantages? It is good for rare case and long and latent period, cases with long and latent period, diseases which takes time to develop. And it is useful because multiple exposure can be studied, multiple exposure, single point in time. It is feasible, cheaper, and of short duration. The odds can be calculated. However, the disadvantages are incidence cannot be calculated because there is no follow-up. Causation cannot be established because there is no establishment of temporality. There may be subjects may be prone to recall bias, and this case may select themselves. It is called as a self-selection bias. They may opt to be enrolled more. This is about the case control study design. To know more about the examples and how to determine and how to calculate odds ratio, etc., please do subscribe to StudyMedic. Coming to prospective cohort study design. From a population, we select those who are already exposed or not exposed, or we may follow up them up to see if they get exposed or not exposed, and then we choose exposed or not exposed. Both are possible, for example, in Framingham heart study. Then we follow them up through the time and see how many of them develop the disease or not. Outcome or development we are following up. Then not only one but multiple outcomes can be studied. Then we calculate the incidence of exposed in disease, incidence of disease in exposed. That is A by A plus B. This is probability. Odds is A by B, whereas probability is A by A plus B. Then we calculate the incidence of disease in unexposed, C by C plus D. C and D are the disease in unexposed, A and B are the disease and no disease in exposed. The ratio between incidence of disease in exposed to incidence of disease in unexposed is called as the relative risk. Now, the retrospective cohort study design, from the present time, we go back and look at the medical registry. From that, we select the population in which whom we are identify the exposed or unexposed. Then through the medical registry, we follow them up to see how many of them develop disease or not, both in exposed as well as unexposed group. And then we similarly calculate the relative risk. This is retrospective cohort study design. Now, what are the advantages and uses? Cohort study designs are useful for rare exposures. Multiple outcome can be studied. Causality can be established because we follow up. Incidence and relative risk also can be studied and calculated because we follow the patient. Adverse drug events can be monitored using the best studies cohort study design. Disadvantages are several. Large number of sample size is needed. They may be prone to selection bias. It is relatively costlier, time consuming. There may be loss to follow up in prospective studies. Also, there may be recall or information bias, and there is no control over confounders in case of retrospective study design. To know more about matching, confounders, bias, incidence, relative risk, etc., do subscribe to StudyMedic Group. Coming to randomized control trials. Here from the population, we randomly allocate people to intervention or non-intervention arm, and there is an allocation concealment. Then there is a blinding, and then we follow them up to see how many of them develop outcome or not in both intervention or non-intervention placebo arm. Then we calculate using the theory of intention to treat or per patient protocol the experimental event rate, which is nothing but incidence rate of outcome in intervention A by A plus B, control event rate, incidence of outcome in no intervention, it is C by C plus D, and can calculate the relative risk. To know more about allocation concealment, randomization, blinding, intention to treat, etc., please do subscribe to StudyMedic. In RCT, the advantages or strength or uses are it is best study to find out the efficacy of intervention. We can find out the superiority trials, non-inferiority trials, and equivalence studies can be performed. It is selection bias is low because we are randomizing, and also confoundings are very less. There is a less information bias. The disadvantages, however, are it is costliest actually, time consuming, may not be feasible, and sometimes not ethical to deny treatment to the people who we know it is useful. It may be underpowered if there is low sample size, and if it is of short duration. It may not be generalizable because strict selection criteria is followed. It may not be suitable for long-term outcomes. For example, drug reactions or drug effects. So these are the advantages and the disadvantages of the RCT. To know more about single, double, triple bind, open-ended, parallel, crossover studies, underpowering, etc., and the clinical trials, please do subscribe to StudyMedic Group. Now coming to effect estimates. These effect estimates may be mean difference, proportion difference, or you can see the following which we are studying further. Now, for example, when we give an aspirin, okay, so 10 of the people develop outcome, 90 do not. Example, when there is aspirin is denied, 30 develop outcome of cardiovascular disease, 70 do not. So this is how we write it in the table. Now, what is the incidence of outcome cardiovascular disease in aspirin group? It is 10 by 100. What is the incidence of cardiovascular disease in unexposed group? It is 30 by 300. Okay. Now, what is the odds? Odds of cardiovascular disease in aspirin is 10 by 90. Odds of cardiovascular disease in no aspirin 30 by 70. This is odds. Then what about the incidence? Incidence is a chance or the probability. Now, incidence of outcome cardiovascular disease in aspirin is 10 by 100. I already told. Incidence of outcome in placebo is 30 by 100. Now, if the exposure reduces the risk, then we can calculate what is called as the absolute risk reduction. In the previous slide, we discussed about relative risk. Absolute risk reduction is incidence in unexposed minus exposed. It is 0.2. Now, what is number needed to treat? How many of them should be treated for one to be benefited? It is 1 inverse of the absolute risk reduction. Okay, if 100 are treated, 20 are benefited. If how many are to be treated for one to be benefited? Okay, that is inverse of absolute risk reduction. Okay, now what is relative risk reduction? So relative risk reduction is absolute risk reduction divided by incidence in unexposed. How much is the risk reduction compared to those who are not given the treatment? This is about 66% can be attributed to this, right? Risk reduction is happening. Now, if the effect or the exposure or the treatment causes increase in the outcome, then we can calculate absolute risk increase. It is IE minus IU. Number needed to harm is similar to number needed to treat. Attributable risk is similar to relative risk reduction. To know more about this and to calculate and to know the solving the problems, please do subscribe to StudyMedic Group. Coming to diagnostic accuracy studies. Now, if the test is positive, for example, fetal fibronectin test is positive and it turns out to be cervical carcinoma by gold standard histopathological test. Now, if reference standard is also positive test and gold standard is also positive, it is true positive. Reference standard is also negative, fetal fibronectin negative, disease is absent by histopathology, true negative. Similarly, false positive and false negative are written by the 2 by 2 table. Now, what is the sensitivity? Now, sensitivity is nothing but, look, amongst those who are having the disease, how many have developed the, how many are tested positive? Amongst those who are having the disease, how many are tested positive? It is called as the sensitivity, A by A plus B, or true positive rate, true positive by true positive plus false negative. It is 90%. Okay. Now, what is specificity? Amongst those who are tested, who are not having the disease, amongst those who are not having the disease, How many are tested negative? How many are tested negative? It is called as a specificity, also called as true negative rate. It is true negative by true negative plus false positive. Here it is 95%. Okay. Now, what is positive predictive value? Positive predictive value is, look at the left to right value. Amongst those who are tested positive, how many of them turn out to be having the disease? That is true positive by true positive plus false positive. Now, what is negative predictive value? Look at the left to right value. Amongst those who are tested negative, how many do not have the disease? It is negative predictive value. True negative by true negative plus false negative. What is prevalence? How many of them are having disease compared to all of them? Total the population size. To know more about what is likelihood ratio, positive, what is likelihood ratio negative, and the relationship between sensitivity, specificity, positive prevalence, predictive value, negative predictive value, and prevalence. And to calculate more about the diagnostic accuracies, do subscribe to StudyMedic group. So in this RRR series, we covered the topics of variables, measures of central tendency and dispersion, representation in graph, normal distribution, confidence interval, inferential tests, hypothesis testing, study designs, effect estimates, as well as diagnostic accuracy studies. And if you subscribe to our StudyMedic group, we will be telling this in detail with more examples, with the solving of the single best answers and EMQs, right? So we know that as StudyMedic group, we have various offering of national and international courses. You can see the following courses are what we offer. Apart from that, 2-year clinical and non-clinical programs are also available. Now, if you subscribe to our group and have an access to our library, one, you will have a live sessions. Two, you will get live session recordings. Three, you will get podcasts, audio podcasts, and preparatory videos based on topic, categorized based on topics. Then also you'll get the mock tests where and daily activities. Okay, which is program is very standardized and scheduled, and one-to-one interaction. Anytime we can contact and solve the your doubts of either through groups or one-to-one interaction. All these facilities are available. So I hope this RRR series for you was very useful to revise, read, and repeat. Do subscribe, like, share to StudyMedic. Thank you. All the best.